higher interrupting rating is required for pool equipment due to the potential for high fault currents, particularly during motor start and stop events. When a motor initiates its operation, it experiences a surge of current known as inrush current. This inrush current can be significantly higher than the motor's normal running current, often reaching several times its rated value. If the circuit breaker does not possess an adequate interrupting rating, this inrush current could potentially cause it to trip prematurely, leading to unnecessary downtime and potential disruptions in pool operation. Furthermore, when a motor is brought to a halt, it generates a phenomenon called back electromotive force or back EMF. This back EMF can manifest as a high voltage spike within the electrical circuit. If the circuit breaker's interrupting rating is insufficient, this voltage spike could potentially inflict damage on the breaker itself, compromising its ability to function properly in the future. The specified 10,000 amp interrupting rating serves as a safeguard, ensuring that the circuit breaker can reliably handle the transient high currents and voltages associated with motor operation without inadvertently tripping during normal usage. However, it also provides the necessary capacity to effectively clear a fault should one occur within the electrical system. Think of it as a balance between preventing nuisance tripping and maintaining the ability to respond decisively to genuine electrical faults. Here's a more detailed breakdown of the factors involved. Firstly, understanding interrupting rating. The interrupting rating of a circuit breaker, often expressed in amps, signifies the maximum fault current that the breaker can safely interrupt without sustaining damage or posing a safety hazard. A circuit breaker with a higher interrupting rating possesses the capability to withstand and safely clear larger fault currents. Secondly, motor inrush current. Motors, especially during startup, draw a substantial amount of current, significantly exceeding their normal running current. This inrush current can last for a brief period, typically a few cycles of the alternating current waveform. The magnitude of the inrush current depends on various factors, including the motor's design, size, and load. Thirdly, back EMF during motor stops. When a motor is de-energized, its rotating magnetic field collapses, inducing a voltage in the motor windings. This voltage, known as back EMF, can be substantial and can potentially damage circuit components if not properly managed. Fourthly, pool equipment electrical environment. Pool equipment often operates in environments that are more susceptible to electrical faults due to the presence of water and the potential for corrosion. This increased risk necessitates the use of circuit breakers with higher interrupting ratings to ensure safety. Fifthly, NEC requirements. The National Electrical Code, or NEC, provides guidelines and standards for electrical installations, including those for swimming pools and related equipment. While the NEC may not explicitly mandate a 10,000 amp interrupting rating for all pool equipment circuit breakers, it does emphasize the importance of selecting equipment suitable for the intended application and the potential fault currents. Sixthly, manufacturer specifications. Equipment manufacturers often specify the minimum interrupting rating for circuit breakers used in their product. These specifications are based on the equipment's design and the potential fault currents that it may encounter during operation. In the case of pool equipment subpanels, manufacturers typically require a 10,000 amp interrupting rating to ensure safe and reliable operation. Seventhly, fault current calculations. Determining the appropriate interrupting rating for a circuit breaker involves calculating the available fault current at the breaker's location. This calculation takes into account the source voltage, impedance of the electrical system, and other factors that can influence the magnitude of the fault current. Eighthly, selecting the correct circuit breaker. Once the available fault current has been calculated, a circuit breaker with an interrupting rating equal to or greater than the calculated value should be selected. Using a circuit breaker with an insufficient interrupting rating can create a safety hazard and may result in equipment damage or failure. Ninthly, coordination with other protective devices. The circuit breaker's interrupting rating should also be coordinated with the interrupting ratings of other protective devices in the electrical system, such as fuses and other circuit breakers. This coordination ensures that the protective devices will operate in a coordinated manner to clear faults quickly and safely. Tenthly, regular inspection and maintenance. Circuit breakers should be inspected and maintained regularly to ensure that they are in good working order and that their interrupting ratings are still adequate for the application. Over time, the electrical system may change and the available fault current may increase, requiring the use of circuit breakers with higher interrupting ratings. Consider an example. Imagine a pool motor with a full load current of 10 amps. During startup, the motor's inrush current could reach 60 amps or more for a brief period. If the circuit breaker had an interrupting rating of only 5,000 amps, it might trip during startup due to the high inrush current, even though there is no actual fault. Conversely, if a ground fault occurs in the pool equipment, the fault current could be several thousand amps. A circuit breaker with a 10,000 amp interrupting rating would be able to safely interrupt this fault current, preventing damage to the equipment and protecting people from electrical shock. In summary, the 10,000 amp interrupting rating requirement for pool equipment sub-panel circuit breakers is based on the potential for high fault currents during motor starts and stops, the need to prevent nuisance tripping, and the importance of ensuring electrical safety in a potentially hazardous environment. It is essential to follow manufacturers' specifications and NEC guidelines when selecting circuit breakers for pool equipment to ensure safe and reliable operation. To further expand on the concepts, let's delve into the technical aspects of interrupting ratings and fault current calculations. The interrupting rating of a circuit breaker is determined through rigorous testing procedures conducted by organizations such as Underwriters Laboratories, or ALL. These tests simulate fault conditions and assess the breaker's ability to safely interrupt the fault current without sustaining damage or posing a safety hazard. The interrupting rating is typically marked on the circuit breaker's label, along with other important information such as voltage rating and current rating. When selecting a circuit breaker, it is crucial to ensure that its interrupting rating is equal to or greater than the available fault current at the breaker's location. The available fault current is the maximum current that would flow in a circuit during a short circuit condition. It is determined by the voltage of the electrical system and the impedance of the circuit. The impedance of the circuit includes the resistance and reactance of the wires, transformers, and other components in the circuit. Calculating the available fault current can be a complex process, especially in larger electrical systems. It typically involves using specialized software or consulting with a qualified electrical engineer. The calculation takes into account the source voltage, the impedance of the utility transformer, the length and size of the conductors, and the impedance of any other equipment in the circuit. The available fault current can vary significantly depending on the location in the electrical system. It is typically highest at the service entrance and decreases as you move further away from the source. Therefore, it is important to calculate the available fault current at each circuit breaker location to ensure that the breakers have adequate interrupting ratings. In addition to the interrupting rating, other factors to consider when selecting circuit breakers include the voltage rating, current rating, and type of circuit breaker. The voltage rating of the circuit breaker must be equal to or greater than the voltage of the electrical system. The current rating of the circuit breaker must be equal to or greater than the load current of the circuit. There are several different types of circuit breakers available, each with its own unique characteristics and applications. Common types of circuit breakers include thermal-magnetic circuit breakers, instantaneous trip circuit breakers, and electronic trip circuit breakers. Thermal-magnetic circuit breakers are the most common type of circuit breaker. They use a thermal element to detect overload currents and a magnetic element to detect short-circuit currents. Instantaneous trip circuit breakers are designed to trip very quickly in response to a short-circuit current. They are typically used in applications where fast clearing of faults is critical, such as in data centers and hospitals. Electronic trip circuit breakers use electronic circuitry to detect overload currents and short-circuit currents. They offer more precise and adjustable trip settings compared to thermal-magnetic circuit breakers. In addition to selecting the correct circuit breaker, it is also important to properly install and maintain the circuit breaker. Circuit breakers should be installed in accordance with the manufacturer's instructions and the NEC. They should be inspected regularly for signs of damage or wear. Circuit breakers that are damaged or worn should be replaced immediately. It is also important to periodically test circuit breakers to ensure that they are functioning properly. Circuit breaker testing can be performed by a qualified electrician using specialized testing equipment. The testing process involves injecting a known current into the circuit breaker and measuring the time it takes for the breaker to trip. If the breaker does not trip within the specified time, it should be replaced. Proper selection, installation, and maintenance of circuit breakers are essential for ensuring the safety and reliability of electrical systems. By understanding the concepts of interrupting ratings, fault current calculations, and circuit breaker types, you can make informed decisions about circuit breaker selection and ensure that your electrical system is properly protected. Furthermore, let's discuss the specific requirements for pool equipment circuit breakers in more detail. As mentioned earlier, pool equipment operates in a potentially hazardous environment due to the presence of water. Water is a good conductor of electricity, and even a small amount of water can create a path for current to flow to ground. This can create a shock hazard for people who are in or around the pool. To mitigate this risk, the NEC requires that all electrical equipment used in or around swimming pools be listed and labeled for use in wet locations. This means that the equipment has been tested and found to be safe for use in environments where it is likely to be exposed to water. In addition to the listing requirements, the NEC also specifies the types of wiring methods that are permitted for use in pool areas. These wiring methods are designed to provide a high degree of protection against electrical shock. For example, the NEC requires that all wiring in pool areas be installed in rigid metal conduit or non-metallic conduit. These conduits provide a physical barrier to protect the wiring from damage and prevent water from entering the conduit. The NEC also requires that all electrical equipment in pool areas be grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The grounding system must be properly installed and maintained to be effective. In addition to the general requirements for electrical equipment in pool areas, the NEC also has specific requirements for pool pump motors. Pool pump motors are typically large motors that draw a significant amount of current. They are also often located close to the pool, which increases the risk of electrical shock. For these reasons, the NEC requires that pool pump motors be protected by a ground fault circuit interrupter, or GFCI. A GFCI is a device that monitors the current flowing in a circuit and detects any imbalances. If the GFCI detects an imbalance, it quickly trips the circuit breaker and cuts off the power to the circuit. This can prevent electrical shock if someone comes into contact with a live wire or a faulty piece of equipment. The NEC also specifies the size of the conductors that must be used to supply power to pool pump motors. The conductors must be sized large enough to carry the motor's full load current without overheating. Overheating conductors can create a fire hazard. In addition to the NEC requirements, local codes and regulations may also apply to electrical installations in pool areas. It is important to check with your local building department to determine the specific requirements in your area. Following the NEC and local codes and regulations is essential for ensuring the safety of people who use swimming pools. By taking these precautions, you can help to prevent electrical shock and other hazards. Moreover, consider the practical implications of these requirements for electricians and pool owners. Electricians who work on pool equipment must be knowledgeable about the NEC and local codes and regulations. They must also be skilled in the installation and maintenance of electrical equipment in wet locations. Pool owners should also be aware of the electrical safety requirements for their pools. They should inspect their pool equipment regularly for signs of damage or wear and should have any problems repaired by a qualified electrician. Pool owners should also avoid using electrical appliances near the pool and should never enter the pool during a thunderstorm. By working together, electricians and pool owners can help to ensure the safety of swimming pools. In summary, the 10,000 amp interrupting rating requirement for pool equipment sub-panel circuit breakers is just one aspect of a comprehensive set of electrical safety requirements for swimming pools. These requirements are designed to protect people from electrical shock and other hazards. By following the NEC, local codes and regulations, and best practices for electrical safety, you can help to ensure the safety of your swimming pool. The importance of proper grounding and bonding within a pool electrical system cannot be overstated. Grounding creates a low impedance path for fault current to return to the source, tripping the overcurrent protective device, like a circuit breaker, quickly. This minimizes the duration of a potential shock hazard. Bonding connects all metallic parts of the pool structure and equipment together, creating an equipotential plane. This means that if a fault occurs, all bonded metal parts will rise to the same voltage potential, minimizing the voltage difference someone might contact and reducing the risk of shock. Regular inspections of the entire pool electrical system are crucial. Look for signs of corrosion, damaged wiring, or loose connections. Any issues should be addressed promptly by a qualified electrician. Remember that even with all safety measures in place, electricity and water are a dangerous combination. Never use electrical appliances near the pool, and always supervise children closely. If you have any doubts about the safety of your pool electrical system, consult with a qualified electrician. Their expertise can help ensure your pool is a safe and enjoyable place for everyone. Ground fault circuit interrupters, or GFCIs, are a critical safety component in pool electrical systems. They are designed to detect even small imbalances in current, which could indicate a ground fault. If a GFCI detects a ground fault, it will quickly trip the circuit, cutting off the power and preventing a potentially fatal shock. GFCIs are required for most electrical outlets and equipment near pools, including pool pumps, lighting, and receptacles. Test GFCIs monthly to ensure they are functioning properly. The test button will simulate a ground fault, causing the GFCI to trip. If a GFCI fails to trip during testing, it should be replaced immediately. Always hire a qualified electrician for any electrical work related to your pool. They have the training and experience to ensure the work is done safely and according to code. Attempting to do electrical work yourself can be dangerous and may void your endurance. Keep electrical equipment away from the pool edge. There should be a clear zone around the pool, free of electrical hazards. Avoid using extension cords near the pool, as they can be easily damaged and create a shock hazard. If you must use an extension cord, make sure it is rated for outdoor use and is plugged into a GFCI protected outlet. Educate everyone who uses the pool about electrical safety. Make sure they understand the risks of electricity and water and know how to respond in an emergency. Post clear warning signs near the pool to remind people of electrical safety precautions. Finally, stay informed about the latest electrical safety codes and regulations. The NEC is updated every 3 years, and it is important to stay up to date on the latest changes. By following these safety tips, you can help to prevent electrical accidents and ensure that your pool is a safe and enjoyable place for everyone.